Okay, in this video we're going to walk through the mammalsleep.R script, which you can find under the week 1 post on the course website. Basic idea here is to explore some of the plotting functions of R, like box plots and dot plots, as well as to show you how R can be used to compute not just some summary statistics, but also to fit very basic statistical models, specifically involving grouping variables, which is probably the simplest kind of model you would imagine. First thing to do is to load the libraries you'll need for the analysis. They are the Mosaic, Graphics, and Faraway library. You almost certainly have Graphics already installed. It's part of the base R distribution. And you almost certainly don't have Mosaic and Faraway. So if you don't, and you haven't installed them yet, just a reminder, go to the Packages tab, click Install Packages, type in the name of whichever you're going for. It'll probably helpfully autocomplete for you, and move from there. I've already installed them, so I don't need to do this step. Once you've installed them, they're there forever, but you will, each time you open R, have to load the specific libraries you need for an individual analysis, so I'll do that here. All right, next thing is to load the name of the data set we'll be working with. This one is called mammalsleep. It lives in the package Faraway, and you notice we don't have to import anything. This one isn't sitting in an explicit file on my hard drive, but rather it's embedded in this library up here. So we go into that line, hit Command-Enter, and now we've got the mammalsleep data set available to us. Just to give you a brief walkthrough of this one, let me double click here, oops, got 2 copies of it here. Every row here is a critter, baboons and chimps and owl monkeys and all sorts of cute little guys. Got all sorts of information about them, their body weight in kilos, their brain weight in grams. We've got how many hours per night they sleep. For example, the Arctic ground squirrel sleeps 16.5 hours every night, quite the envy of most college freshmen. And that number of sleeping hours is broken down by dreaming hours and non-dreaming hours. And you can see there's some missing data here. We don't quite know how much the Arctic ground squirrel is dreaming, even though we know it's sleeping quite a lot. Then over here, there's some ecological variables about these animals. Predation is a predation index. The higher the index here, the more likely that ecologists are judging that animal is to be eaten by some other animal. So you can see, what's the 4th row here? Arctic ground squirrel has a 5, quite likely to be eaten. The Arctic fox has a 1, very unlikely to be eaten, all other things considered. Then there's exposure, which is how exposed the animal is at night when it's sleeping. Is it in a cave, in a burrow, or out in the middle of a field somewhere? And danger is a composite of these 2 variables. All right. Working hypothesis here is that dreaming hours, how many hours per night an animal is dreaming, is going to depend in some way upon these environmental variables, in particular, how much in danger an animal is when it's sleeping. Let's take a look at that, look at a few simple graphs, and investigate whether there's at least any visual evidence for that hypothesis. Okay. I'll look at a few summary statistics first, just to remind you of this command. You can always feed a data set or a data frame here into the summary function and get out some basic summary statistics about the variables in the data set, quartiles and minimums and maxes and means and that sort of thing. Okay, I'll look at a histogram here. It's the dream variable we're interested in. That's the outcome here, how many hours per night the animal is dreaming. It's a column or a variable name in the mammal sleep data set. So remember, data set $, variable name. Get a histogram. Not very many breaks there. I think I want something slightly more granular, so I'll feed a number of breaks. I'll only ask for 20. Notice R takes that more as a suggestion than a command. It's not exactly 20 over here, but it's close enough. And I'll make a table. For a categorical variable like danger here, it's given a numerical code, but really it's more like a category from least in danger to most in danger. So if I've got a categorical variable, I might just want an estimate here, or in fact an output of how many counts, how many particular animals live in each category. And I'll do that with the summary command, and quick problem here. We notice that R thinks that danger, because it's coded as a number, is a quantitative variable, and it's not. It's a category label. So we have to recast it as a factor, and we do that with the factor command. Feed the variable name into the factor command, and I'm just going to overwrite mammalsleep$danger with a new version of itself. And you notice if I try that summary command again, now I get category labels, category 1, 2, 3, 4, and 5, and counts. 19 animals in the first category, 9 in the 5th, etc. Now let's look at a box plot. And the syntax here, this syntax, just you should be aware, is something that's made available by the Mosaic library. So if you haven't loaded the Mosaic library and you try this command, you're going to get an error. The syntax is response tilde predictor. Response is modeled by predictor. Here we would like a box plot of number of hours per night an animal dreams, stratified by the categorical variable of how much in danger they are. So hit that, and you notice here we go. We have a box plot. And just as we might have expected, the animals that are least in danger here, category 1 for the danger variable, dream the most on average. Those in the most in danger of being eaten while they sleep dream the least. There's another kind of plot you could try. I call it a dot plot. R insists on calling it the rather inelegant name of a strip chart. And just like the box plot command, syntax is exactly the same. And okay, you'll just see what this is by example here. It's instead of boxes, you get actual dots, so that the individual observations aren't obscured, reduced to a set of summary statistics. So here now on the vertical axis, we get the categories, category 1, 2, 3, 4, and 5. And here on the horizontal axis, we get the outcome variable. I happen to like predictors on the x-axis and responses on the y, so I'm going to ask for a vertical strip chart, which we do by adding the vertical equals true flag after a comma to be all the other flags to the strip chart command. And sure enough, now we get something that looks a lot more familiar. It's almost like a box plot, except dots instead of boxes. So a dot plot like this is fine for a small data set like this. You can imagine, however, that if you had lots and lots of data points per category, that they might start all piling on top of one another, and you'd have a real hard time of seeing anything meaningful there. So there's a helpful command called Jitter that allows you to, as the name would imply, add a horizontal jitter to some of the points. Notice they just got twiddled a little bit left and right. And that's just a random amount of jitters, nothing systematic in it. And I do this a few different times, and you notice I get a few different jitters. So sometimes that's helpful in allowing you to disambiguate individual points on a dot plot. Next thing we'll do is actually compute the means, which is to simply ask for each category, category 1 through category 5, what is the mean of dreaming hours per night for animals that live in that group. And I do that again with a similar kind of syntax, mean of response twiddled by predictor for this data set. So dreaming hours stratified by danger index. And I'm getting some NAs, which is super annoying, but a fact of life when you're dealing with real data sets. Let's go back up here. Notice we have some missing data, NAs, for dreaming hours for some of these animals. And what we'd like to do is scrub those NAs from the data set. Of course, we don't want to delete those rows entirely. Maybe we want to do something else with them. And so there's kind of these temporary deletion commands that R has, basically telling you, within the context of this command, ignore all those involving NA, the missing data. And then you do that with the NA.rm for NA remove equals true. So you notice what happens when I use this command. Now instead of NAs, it doesn't know what to do in taking the mean of a missing value. Now I've got the non-missing values, and bingo. We've sort of got the same kind of trend, except as summary statistics rather than a plot. Higher number of dreaming hours per night on average for those in category 1, least danger, compared to fewer dreaming hours for those in category 5, most in danger. I could also do this by computing the groupwise standard deviations with the SD command. Higher spread here in the higher categories, and you can see that very clearly over here in the dot plot. So that's computing the means and just kind of spitting them out here to the console. There's another way to compute groupwise means, and that's using this LM command, which stands for linear model. Linear models are, using the LM command, are fit by least squares, which is something we'll talk extensively about this semester. Just for grouping variable, if I feed it a categorical variable as a predictor in a least squares model, it will do the exact same thing that I'm asking when I ask for it to compute the means. It will just phrase it in a slightly different way that I'll show you here. Let me take LM command and feed the output into this variable that I'll call LM1. So LM is a function and LM1 is a variable now. Nothing happens down here in the console, but hey, something happened up here telling me now I've got this value LM1 stored in memory. Let's do some things with it. You can use the coef command and feed LM1, this outcome here, into the coef command to get the coefficients in the model. And this is going to give me some different formatted information over here. I'm getting an intercept and then these things that are negative, which is, there's no negative values in the data set, so you might be wondering, what's that about? Let's put them side by side with the group means. Okay, so here, if I just use this command right here, I'd get things spat out to the console, but instead I'm going to take that information, I'm going to save it in this variable that I'll call group means. And now I'm going to put those group means stacked on top of each other with the coefficients from this LM1 that I fit up here. I'll do that with the command rbind for row bind, stacking things on row by row on top of each other. You notice, okay, for category 1 here, these two numbers are the same, and these numbers aren't. So I'll leave it to you to interpret what exactly is going on here? Why am I getting a different set of numbers? What's the relationship of the first row to the second row? Hint, these numbers are conveying exactly the same set of information, just in a slightly different language.